So let's look at example 3 and see how we can use what we've learned today to solve a real world problem. Okay, we've learned how to take a function rule and make ordered pairs for that function rule, and then graph that information, and then find the slope and the y-intercept of that graphed line. So example 3 tells us Kaylee had a $3 coupon to use at her favorite restaurant. If every hamburger costs $4, the function y equals 4x minus 3, that's our function rule, will represent her cost before taxes. Graph the function and use the graph to determine how many hamburgers she can buy with $15 of cash. Okay? So, here's what we want to do. We want to make some ordered pairs. So give me some input values. What do we want to try? We'll try 1. We can try 3. We can try 5. So what's my output if my input is 1? 4 times 1 is 4, minus 3, 1. What's my output if my input is 3? 4 times 3 is 12, minus 3, 9. What about if my input is 5? 4 times 5 is 20, minus 3, 17. I don't think I'm going to have 17 squares on my graph, am I? So let's replace the 5 with something smaller. I'm not even sure if I have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, that goes right to the edge. Let's replace that with something smaller than 5. Let's try -2. Okay, so 4 times -2 makes -8. Oh, that won't work either because that's going to make an 11, and we don't have room for 11. Let's go with a -1. 4 times -1 makes -4, -5, -6, -7. Okay, so we now have 3 ordered pairs that we can graph. We've got 1, 1, 3, 9, and -1, -7. Okay, so let's graph these. Where am I going to graph 1, 1? 1x, 1y, right here, right? What about 3 and 9? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, right here. What about -1 and -7? -1, 1, 2, 3, 4, 5, 6, 7, right here. Okay, now let's connect those. Let's connect those with our, with a line. Okay, after you connect the graph dots, always go past your dots and then put arrowheads on the end, because a line keeps on going in both directions indefinitely, right? And we always graph a line, not a line segment. So you want to go past the dots and put arrowheads, okay? So we've graphed this now. Now let's find the slope and the y-intercept, because that could give us some important information. So I'm going to have to erase our table of ordered pairs here. What's the slope of our line? No, look at, remember, to find the slope, we're comparing it to mx plus b, and m is slope. So our slope is 4. What's our y-intercept? 0, -3, right? So this is our y-intercept right here, 0, -3. That's where our line crosses the y-axis, and our slope is 4. Okay, now our example problem said figure out how many hamburgers this girl, Kaylee, can buy if she's got $15 of cash. Okay? So, in our function rule, the number of hamburgers is the input value, right? and the output value is the cash. So if she's got $15 cash, 15 is the Y value. So if my graph continued all the way to 15, where would I be at? At what point would my line intersect with 15 on the Y line? So ours goes up to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if we added 5 more pieces up here, basically 11, 12, 13, 14, 15, if we went up this high to 15, which would be about here, where would that put us on the X line? Well, if we had a piece of paper, we could actually draw that out, but it looks to me like it probably is going to put us about here. 1, 2, 3, 4, 5. Maybe we would be at 5 on the X line when we get to 15 on the Y. It actually looks like we would be at 4.5, so that was a pretty good guess. We would be at 4.5 on the X line when we hit 15 on the Y line. So since you can't buy 4.5 hamburgers, she can probably buy 4 hamburgers with her money, with $15 of cash. Okay, let's look at an assignment for this lesson. So we're going to do one through 10. All of them. And then we're going to do 19 and 21. And then let's do number 26 and 28. Okay, for this lesson, those are the problems that we'll do for 14.4.